So I'll start from the solution to the assignment given in the last class. I don't know if the person present today was at the last class. Were you? Hello? Hello? Okay. I gave 3 questions for the assignment last week. The first one was, pardon the way I wrote my power. That's what I could do with my phone because I presented the slide with my phone. I'm not with my system presently, so I had to use my phone. So the first question is 30 a raised to power 5 b raised to power minus 8 divided by 6 a raised to power 3 b raised to power minus 5. So we are asked to solve this. Now, the first thing to do is, I wrote this out as normal division. We have 30 raised to power 5. You said?
Yes, are you there?
Yes, I'm here. Can you hear me? Can you hear me?
Yes, yes.
Okay. So I said the first thing I did was write this out as normal division, 30 raised to power 5, b raised to power minus 8, all over 6 raised to power minus 3, b raised to power minus 5. So expressing this as individual term, taking that expression, question 1, and expressing it as an individual term, and then collecting like terms. Looking at 30 a raised to power 5, b raised to power minus 8, all over 6 a raised to power minus 3, b raised to power minus 5. So I picked 30 divided by 6. 30 and 6 are ordinary numbers. So we have 30 divided by 6 times, because when we split 30 raised to power 5, b raised to power minus 8 into each term, we can have it as 30 times a raised to power 5 times b raised to power minus 8, all over 6 a raised to power minus 3. 6 times a raised to power minus 3 times b raised to power minus 5. So that will give us 30 divided by 6 times a raised to power 5 divided by a raised to power minus 3 times b raised to power minus 8 divided by b raised to power minus 5. Collecting like terms. So when we solve this division individually, 30 divided by 6 will be solved as a normal division terms, given that they are not indexed. They don't have an index or an exponent. They don't have a power. So we solve this normally. So 30 divided by 6 will give us 5. And then times a raised to power 5 divided by a raised to power minus 3. Applying indices rule to that term, a raised to power 5 divided by a raised to power minus 3. Applying the rule of indices where our division sign changes to minus. That gives us a raised to power 5 minus 3. Do you understand that? Hello? A raised to power 5 minus 3 times we come to b. B also, applying the rule of indices, we have b raised to power minus 8 minus 5. This division sign in between b raised to power minus 8 and b raised to power minus 5 changes to minus. So we have b raised to power minus 8 minus. And in mathematics, we know that minus times minus gives us plus. So from here, we have 5 times a raised to power 5 plus 3. 5 minus 3 times minus changes to addition. So that gives us a raised to power 5 plus 3 times b raised to power. So from here, we have 5 times a raised to power 5 minus 3 times b raised to power minus 8 minus 5. That gives us 5 times, in bracket, a raised to power 5 plus 3 times, in bracket, b raised to power minus 5 plus 8. When we solve that, we have 5 times a raised to power 5 plus 3 gives us a raised to power 8 times b raised to power minus 8 plus 5 gives us b raised to power minus 3. Minus 8 plus 5 gives us minus 3. I don't know if you understand that. Can you hear me? Can you hear me? When we multiply this and we write it out as an expression, this gives us 5a raised to power 8, b raised to power minus 3. So that is the solution to the first question. 5a raised to power 8, b raised to power minus 3. The second question says that 3x raised to power 2, y raised to power 3, raised to the power of 5. Oh, there's a mistake there. 3x raised to power 2, y raised to power 3, raised to the power of 5. Now, to solve this, first thing we must note is that this power of 5, the 5 that is outside the bracket, is a power, and it belongs to each of the term inside the bracket. I don't know if you understand what I've just said. This power of 5, this power of 5 outside, it's not just 5, it is power of 5. I made a mistake. Power of 5. The power of 5 belongs to 3x. It belongs to 3. It belongs to x raised to power 2. And it belongs to y raised to power 3. So when we solve this, when we write this out in separate term, we can have what is inside this bracket, which is 3x raised to power 2, y raised to power 3, raised to the power of 5. We can have it as 3 times x raised to power 2 times y raised to power 3 to the power of 5. So separating this expression into different terms, this gives us 3. We pick collecting like terms, or we pick each term. 3 stands on its own. So this gives us 3 raised to power 5, expanding the bracket. When we expand the bracket, we have 3 raised to power 5 times x raised to the power of 2 raised to the power of 5. 3 raised to power 5 times what? X raised to the power of 2 raised to the power of 5 times y raised to the power of 3 raised to the power of 5. When we solve this, 3 raised to power 5, 3 times 3 times 3 times 3, 3 in 5 places gives us 243. 243 times x raised to the power of 2 raised to the power of 5 gives us x raised to the power of 2 times 5. X raised to the power of 2 times 5 times y raised to the power of 3 raised to the power of 5 here gives us y raised to the power of 3 times 5. This equation leads us to the next, which is 243 times x raised to the power of 2 times 5 gives us x raised to the power of 10 times y raised to the power of 3 times 5 gives us y raised to the power of 15. So this equation gives us 243 x raised to the power of 10, y raised to the power of 15. Hello? Hello?
Hi.
Welcome. Those that are just joining us. So today I'm sharing a slide. I'm not writing on the board. I'm explaining the solution to the assignment I was given last week, Sunday. That was last week, Sunday. So I've done question 1 and 2. I don't know, maybe when you watch the recorded class online, if you have any question, you can drop it on the comments at the comment section. I'll try to check it out. So I'm moving to question 3, solution to assignment given last week. Question 3, we have, oh, okay. Sorry, I'm coming. So this is question 3. We have it as 16. Oh, I was trying to get the, okay. I corrected. Oh, well, sorry. Okay. The question, what is on my slide is quite different from the question. I was trying to correct it, but it's like I'm not getting the corrected version. Okay, let me just explain like that. Question 3. We have, the question is 16 over 81 in bracket raised to the power of minus 3 over 4. 16 over 81 raised to the power of minus 3 over 4 times square root of 100 over 81. I did not put square root here. That's what I was trying to get, the corrected version. There's a square root in this 100 over 81 times square root of 100 over 81. Now, the solution to this is we pick each term. That is, we pick 16 over 81 raised to the power of minus 3 over 4. And then we pick on square root of 100 over 81 and solve separately. So, solving the first term, which is 16 over 81 raised to the power of minus 3 over 4. Last week, when I was explaining fractional indices, I said when we are giving fractional indices, looking at our indices here, that is our power, we'll see it's in fraction form, minus 3 over 4. So when we are working with fractional indices, I said you would express your base as a multiple of the denominator of your power. What do I mean by that? As relating to this question, our base in this first term, 16 over 81 raised to the power of minus 3 over 4 is 16 over 81. 16 over 81 is our base, and minus 3 raised to the power of 4 is minus 3 over 4, is our power. Minus 3 is the numerator, while 4 is our denominator. We have to express the base in this form, which is 16 over 81, as a multiple of the denominator of our power, which is 4. That is, you are breaking 16 down, and you're also breaking 81 down to a multiple of 4. Now, how do we go about that? We can say 4 times 4 gives us 16, right? Which is relating to minus 3 over 4. Now, looking at 81, how do we break 81 down? We can also say 9 times 9. 9 times 9 does not relate to the power of minus 3 over 4. So what do? We can break down 9 times 9 into simpler numbers. So we have 3 times 3 times 3. That will give us 3 in 4 places. That is 3 raised to power 4 is the same thing as 81. And then when you look at 16, we can also break 16 down to 2 times 2 times 2 times 2, 2 in 4 places. 2 raised to the power of 4 will give us 16. Now, having 2 raised to the power of 4 in place of 16 and having 3 raised to the power of 4 in place of 81. This power of 4 has a relation to the denominator of our power, which is minus 3 over 4. Do you understand what I'm explaining? Hello?
Hi.
Am I being understood?
Yes, ma.
You are sure?
Yes.
Okay. So this gives us, when we expand the bracket, separating this the numerator and the denominator of the whole term, because the power of minus 3 over 4 belongs to 16 and 81, not just 16. So if we break this down, we have it as 2 raised to the power of 4, bracket of 2 raised to the power of 4, close bracket, to the power of minus 3 over 4. And then we have the denominator as 3 raised to the power of 4 in brackets. When you close the brackets, we have to the power of minus 3 over 4. Now, when we open that bracket, when we expand it, we have 2 raised to the power of 4 times minus 3 over 4. 4 times minus 3 over 4 is our power. When you look at the laws of indices, this is one of the law, your power rule, not the multiplication rule changing to addition. Now, the power rule. When you have power outside the bracket, you have to multiply with the power inside of the bracket. So we are multiplying minus 3 over 4, which is outside the bracket, with the power of 4 inside the bracket. So we have 2 raised to the power of 4 times minus 2 raised to the power of minus 3. Doing the same for the denominator, we have 3 raised to the power of 4 times minus 3 over 4. That gives us 3 raised to the power of minus 3. And this gives us 2 raised to the power minus 3 over 3 raised to the power minus 3. Now, applying the law of indices also to this point we've gotten to, we will be using the negative indices. I could remember last week when I was explaining the negative indices, I talked about reciprocal. Now, having 2 to the power of minus 3, when you have a negative indices, it means 1 over the 2 raised to the base to the power of the positive power. 2 to the power of the positive of that power. For instance, we have 2 raised to the power of minus 3. Applying the negative indices to this, we have 1 over 2 raised to the power of positive 3. We have a positive power. The reciprocal of 2 raised to the power of minus 3, that will be 2 raised to the power of positive 3. So we have 1 over 2 raised to the power 3, all over 1 over 3 raised to the power of 3. Do you understand that point?
Yes, ma.
Hello?
Yes, ma. I understand.
Do you understand?
Yes.
You are sure?
Yes, ma.
So when we separate the numerator from the denominator, we have 1 all over 2 raised to the power 3 divided by 1 over 3 raised to the power of 3. Now, changing the division sign to multiplication, as we do in mathematics, we have 1 raised to the power of, 1 divided by 2 raised to the power of 3 times 3 raised to the multiplication sign. You interchange the denominator and the numerator. So we have, this gives us 1 over 2 raised to the power of 3 times 3 raised to the power of 3 over 1. 2 raised to the power of 3 is 8. So this gives us 1 over 8 times 3 raised to the power of 3 is 27. So that gives us 1 over 8 times 27 over 1. So we have 27 over 8. That's the first term, which is 16 over 81 raised to the power of minus 3 over 4 from the first question. Now solving the second term, which is square root of 100 over 81. Permit my mistake. Square root of 100 over 81. In indices, square root is the same thing as the power of half. If you say square root of 100 now, we have it as 10. When you say 100 raised to the power of half, it will give you 10. So square root is the same thing as saying to the power of 1 over 3. Cube root is the same thing as saying to the power of 1, square root is saying to the power of 1 over 2. Cube root is the same as saying to the power of 1 over 3. So changing our square root to the power of half, changing it to 1 of half. I will send the correct third copy of question 3 to Mr. Jason. It would help me forward it to the students. So we have the square root of 100 over 81, turning it to, in bracket, half. Now, if we have 100 over 81 into bracket of the power of half, like we have been told that when we have a fractional indices, you express your base, you turn it to a base and a power, and the power should have a relationship or should be broken down into the multiple of the power, the denominator of the power outside of the bracket. Now, the power outside the bracket in this case is 1 over 2, and the denominator is 2. Now, we want to break down 181, 100 over 81. We want to break it down to powers that have relationship with 2. So we can simply say 100 is the same thing as 10 raised to the power 2, and 81 is the same thing as 9 raised to the power of 2. So this gives us 10 over 9 into brackets, all raised to the power of 2. 10 over 9, all raised to the power of 2. Now, there should be another bracket where we have it to the power of half. When we solve that equation, 10 into the bracket to the power of 2 to the power of half. 1 over 2 times 2 gives us 1. So in the long run, we have 10 over 9 raised to the power of 1, which gives us 10 over 9. Having solved the first term and the second term, and we've gotten 28 over 7 as the first term and 10 over 9, 16 over 81 raised to the power of minus 3 over 4 times 100 over 81 gives us 27 over 8 times 10 over 9. Do we understand this point?
Yes, ma'am.
We have 27 over 8 times 10 over 9. When we multiply 27 over 27 times 10, it gives us 270. When we multiply 8 times 9, it gives us 72. Reducing 270 over 72 to its lowest term, I divided both the numerator and the denominator by 9, which gives us 30 over 8. 30 over 8 can further be divided. So we have 30 divided by 2 over 8 divided by 2. That gives us 15 over 4, which is 3 whole number 3 over 4. Do you understand?
Yes, ma'am.
So now to the main class of today. Yeah, I'll be sending a corrected version of that to Mr. Jason, probably tomorrow or Saturday. So now we move to the main class of today. Today we'll be dealing with standard form.
Can you hear me?
Yes, I can.
Do you want to present on the board now?
No, I'm not presenting on the board. I'm still using slide.
Why didn't you? Why